Hello and welcome to the Linux command line video series. In this video, we will look at the awk pattern scanning and processing language. Please help me out by hitting the subscribe button so I can learn to dance the Macarena. Awk is a pattern processing language. It breaks down each line as fields separated by a field separator or delimiter. It is most effective when looking at text files that are formatted in a known manner. It will parse each line of a file looking for patterns and then executing accordingly. So the command line starts off with awk, and then a single quote. And then within slashes, you have the pattern that you want awk to match. And then within curly braces is going to be the action that awk is going to take once the pattern matches for that line. And then you end that by a single quote. And then the last thing is the input file that you want awk to process. The pattern argument is actually optional, and we default to matching anything. And then the action argument is also optional, and will default to printing the line as it sees it. But you must have either the pattern or the action. So for example, if we do awk curly braces with print, and then we're going to read the /etc/fs tab file. Because we did not put the pattern, it's going to match everything, and then the action that we're telling it is just to print the line as it sees it. So this will just display the file, much like the cat command. We can also do awk and then // with nothing in between to match everything. And then specify the input file as /etc/fs tab. This time, because we did not specify any action, it defaults to printing the line. And because our matching is an empty matching set, it's always going to be true. So essentially, once again, this is equivalent to catting the file. Instead of specifying an input file, you can also just pipe the output of another command into awk as the input file. So in this example, if we do just ls-la and then pipe that into awk // it will basically just give you the output of ls-la. Let's break it down and look at the types of patterns we can use for awk. The simplest is just a string you are interested in. So for this example, I want to see all files that have the string $DO within its name. So I can do ls-la, pipe that to awk, single quote, /$DO, / open braces, print, close braces, single quote. And we get back two directories that start with D and O. We can also use regular expressions for the pattern. So for this example, I want to match anything that contains a capital P or a capital T and then ends in a letter S. So I'm going to do ls-la again and pipe that into awk. And then single quote, / open bracket, capital P, capital T, end bracket, dot plus, $S, / and then open braces, print, end braces, single quote. So let's look at the regular expression. So within the brackets here, I have capital P and capital T. So what that says is that I want to match either a capital P or a capital T. And then the dot plus means one or more characters of any sort. And then lastly, I want to have a letter S, which is going to be the last character of the line. That's what the $sign stands for. And then if that matches, I'm going to print that out. So once we hit return, we get back two directories One that starts with a capital P, one that starts with a capital T, and they both end in S, fulfilling the regular expression match. Now let's take a look at what we can do in the action field. We've seen previously that we can print the entire line that matches a condition. So if we do ls-l of .config/caja, pipe that into awk, and then just put single quote open braces print and curly braces single quote. This will just essentially list out all of the files in that folder. Internally, awk also divides each input line into fields. The way it delimits each field is by the field separator, which is set to whitespace by default. And by whitespace, we're talking about spaces and tabs. So for the output of ls-l, here are the ways that the fields are divided. So here is field number one, $1, right? After the space is going to be field number two, $2. After the next space, it will be field number three, $3, etc. And then the entire line is referenced as $0. And we can print out the individual fields. So if we just go up arrow, and now we want to add the $9, $5. So what this is going to do is that it's going to do the ls-l command again on that folder. And instead of printing out everything, we're only going to see the name of the file, which is $9, and then the size, which is $5, the fifth column. And between the $9 and the $5, we put the comma, which basically adds a space in between the output. And we can also print out other text by adding them in quotes. So let's go up arrow again. And this time we're going to add in double quotes file name : before the $9. And then between $9 and $5, we're going to get rid of that comma and add our own space within this double quote here. I'm going to put space size : So now as we hit enter, we're going to have output that says file name is whatever the file name is, and then after space, it's going to tell you what the size is for that file. We can also use formatted text to print via the printf command. So let's go back up arrow again, and then instead of print, we're going to use printf. And now we're going to put it within parentheses what we're going to print out. So we're going to put double quote %s : space %d/n end double quotes comma $9 comma $5 end parentheses end braces and single quote. So what this says is that we're going to print the string here, which is represented by $9, and then we're going to put the decimal, which is going to be represented by $5. So now when we hit enter, it's going to print out the file name : and then the size, and then set bytes. And then lastly here in the printf, the /n means new line. All right, so if we don't put that, it's not going to have any new lines for every line that it prints. It's going to jam them onto one long line. All right, let's move on to expanding our action here. We can also have conditions. Within the awk language, they can have testing conditions and loops, for loops and while loops and so forth. So let's say in this instance, we only want to print out lines where the size of the file is over 1 kilobyte. So let's go back up arrow again. And then what we're going to do is before the printf, we're going to add our condition. We're going to say if parentheses $5, which is the size field, greater than 1,000, and then end parentheses, we're going to go ahead and do the print. Right? So once we hit enter, now we only see lines where the file size is over 1,000 bytes. So if we look back at our output from 2 commands ago, It is looking pretty good, but there's some minor cleanup to do. As you can see, the first line of output from the ls does not conform to the rest of the output, so our awk program is not handling it properly. Within awk, there are a few system variables that we can use. One of them is the variable nr, whose value is the number of the current record. So if we don't want to process the first line, we can add the condition that only if the current record number is not 1 do we take any action. So if we go up arrow, we can add the condition of if open brackets nr is not equal to 1 end parentheses. Then we hit return. You notice the first line where it used to print some weird stuff is no longer being printed. There's also the begin and end variables that instruct awk to perform its associated actions before processing and after processing respectively. So we can add a header and a footer to our output. Let's use the begin statement to print a header and use the end statement to print a summary. This is what the syntax looks like. You have awk, and then the single quote, and you have begin, and after that within curly braces you have the first action. Then you have your pattern within forward slashes, and then after that you'll have the second action within curly braces. Then you have the end section followed by curly braces, which contains the third action. And once again, you end the quotes, and then you have your input file. So let's go ahead and up arrow and add the begin and end. So we're going to use your arrow key to go all the way back, and then here we're going to add the words begin, and then within the curly braces we're going to say printf double quote file name colon file size /n for the new line, and then end the double quotes and end the curly braces. Then we're going to use the arrow key to go all the way to the end, and then type end, open curly braces, print, double quote number of files, colon, end double quotes, comma, nr minus 1, end the curly braces, and then the single quote. All right, let's read through what this means. So basically, within this section here, we have the begin. So the first thing it does before any processing is that it's going to print out what we call the headers, right? We're going to have the file name colon and then file size. And then the second section is that we're going to have it take some action and on every line. And basically, the condition is that as long as it's not the first line, we're going to print out the file name and then the number of bytes. And then this last section here, this end section, we're basically going to print the number of files that we just processed. And essentially, that's the number of records minus 1, right? Because the first line of ls is not a file listing. So once we hit the enter key, we see that it's printed out the header. It's printed out all of the contents of this folder with the names and then the bytes. And then lastly, it tells us that it's processed 3 files. Another system variable is the field separator, which sets the field separator to something other than a white space. A good example would be the etc password file, which uses the colon as the field separator. So if we try to print out the username and shell for that user, we would get results which are not valid. Right? So if we do awk single quote brackets print $1, $7, end curly braces single quote /etc password, it essentially reads everything up to the first space as our first field. And then it will look for 6 other spaces in between until it gets to the 7th field. And essentially that just doesn't happen because we don't have that many spaces. So this is definitely not correct. But if we add the -F option to change the field separator to the colon, then we get the desired result. So I'm going to up arrow and then backtrack here, -F, double quote, colon, double quote. Now we hit enter, and we can definitely see the user and then the shell that the user runs when they log in. So that's how you can change the field separator if your fields are not a white space. Let's look at some possible cybersecurity usages of awk. When an attacker hacks into your Linux system, it is possible that they'll want to create a new user so that they can log back in at their leisure. One thing you should check is the etc password file. Let's arrow up to the command when we view the etc password file. Let's add a pattern such that awk will only print a line when it does not match the words no login or false, which basically means there is a login shell for that user. So I'm going to type awk -F, double quote, colon, double quote, single quote, exclamation mark, slash, no login, slash, and, exclamation mark, slash, false, slash, open braces, print, $1, comma, $7, end braces, end single quote, slash, etc password. So on our Kane distro system, we see there are a few users who can log in, and then there are a couple of added ones, used for this video. And we see here that there is a suspicious account named maintenance, which is running the dash shell when everybody else is running a bash shell. Another place we may look for intruders is the file var log auth.log, which stores login attempts. Let's use awk to look for the word sudoers, which is for the substitute user, and then not blue monkey, just to make this example cleaner. So we're going to type in sudo awk -F, double quote, colon, double quote, single quote, sudoers, slash, and, exclamation mark, slash, blue monkey, slash, open braces, print, end braces, single quote, var log slash auth.log. Here we see failed attempts for the user maintenance as they attempted to use the sudo command. This could be legitimate, or it could be an intruder testing out what they can do on your system as they are testing out the sudo capabilities. Lastly, remember that these Linux tools are not just for Linux machines. You can use these tools to perform analysis on Windows machines. Here we have a Windows SAM hive that we have located, and we can run a regripper on it and then pipe the output to awk, where we can filter out what we want to see. So the command we're going to type is rip.pl -lowercase r sam -p sam parse, pipe it to awk -lowercase f sam parse.awk. So the -r is to read in the SAM registry. The -p for SAM parse is going to be the parser that we're going to use. And then the samparse.awk file is the awk script. For this example, we created a file named samparse.awk, which contains our awk statements. We can then read in the script with the -lowercase f option. And I figure since we're going to be running it this frequently, we might as well keep it as a script so we can use it over and over again. So now let's take a look at the samparse.awk file. We're going to have a begin statement, which prints out some headers. And what we're going to do is we're going to specify our field separator to be a colon. And then we're going to print the header of username, SID, tab, login count. And then after that, what we're going to do is look for the keyword of username. And then we're going to print out the second column once it sees the username, which is the username with the tab. And then this last part here is just to make it fancier. We're going to say if the length of that variable, that username variable, is less than 16 bytes, we're going to add another tab just so that it looks prettier. And then lastly, we're going to look for the word login count, and then we're going to go ahead and print that number. And once again, we're going to make it prettier by, making it 2 decimal places with the printf. So each output we have contains the username, and then some appropriate number of tabs, and then the number of logins as kept in the registry. And so this basically prints out the header as we expected, and then every time it sees username, it'll print out the username, and then subsequently the number of tabs, and then the login count. So once again, this is a Windows registry that we're looking at, but we're using the Linux tools. So don't forget, these tools that we talked about is good for pretty much any system because the files are the files. All right, so that brings us to the end of this video where we learned about the awk pattern processing language. Hope this will be useful for you, and if so, click on the thumbs up icon to like this video. Please hit the subscribe button to get notified when the next video comes out. Also, please leave me messages in the comment section below so I know what you liked and didn't like, or what you may want to see in future videos. See you next time.